This is AP Calculus 610 Part 1, and in this section we're going to integrate using long division. Sometimes you'll be given an integration problem where the degree of the top is either equal to the degree of the bottom or the degree of the top is higher than the degree of the bottom. And if you try to look for a natural log situation where you've got a derivative over an original, you can't have that. If you think about the nature of a derivative, if we take the derivative of a function, isn't its degree going to go down by 1? So if we have a derivative over an original, then the top degree is never going to be higher or equal to the bottom degree. So we can't have that situation unless the degrees match what we need them to be. So if your degree on top is the same or higher than the degree on the bottom, there has to be a better way to deal with that problem. And there are a bunch of things you could try, but I'm going to show you the easiest thing to do today. Now, some people might try to take the x squared and rewrite this as x squared over x squared plus 1 plus x over x squared plus 1 plus 1 over x squared plus 1. But then you have created 3 problems out of 1, which is going to make it a lot more difficult to solve, and sometimes you may not even be able to get it to work. So what you need to do here is you need to rewrite this problem so that you're not changing its value, you're just making it look different, and that thing that makes it look different enables you to be able to integrate it as well. So what we're going to do, and again, you only do this when the degree of the top is either the same as the bottom or higher than the degree of the bottom. It won't work otherwise. We're going to use long division to rewrite this problem. So what I'm going to do is I'm going to put the top expression inside the long division symbol, and I'm going to put the bottom expression, that's what I'm dividing by, on the outside. Now, when I do that, I have to make sure my powers are in descending order. If I'm missing any powers, I need to put a 0 in there. So like if this had been x cubed plus x plus 1, then I would need an x cubed plus 0x squared plus x plus 1. Here, this is x squared plus 1. I'm missing the x term. So out here, I'm going to write it as x squared plus 0x plus 1. Now, some people can do that without writing the 0x, but I want to make sure we are accounting for that so that you can see why these things cancel out as we go. So if I do that, now remember, if you recall long division, we just divide the first term into the first term. The rest of them will take care of themselves as you go through the problem. So how many times does x squared go into x squared? Well, it goes in 1 time. So 1 then multiplies by our divisor. 1 times x squared is x squared. 1 times 0x is 0x. 1 times 1 is 1. Then I subtract to be able to figure out what's left. Well, x squared minus x squared is 0x squared, which is what we want. We want that first term to cancel out. X minus 0x is x, and 1 minus 1 is 0. So it looks like we have a remainder of x. Now, x is not divisible by x squared. You can't take x squared and go into x. It's not going to work. So we don't have any more division to do. We're finished with that division. This is our remainder. Now, keep in mind, when you have a remainder, can't you take that and put it over the divisor? So that's what I'm going to do. X, so that was a positive x, so it's going to be a plus x over the divisor, which was x squared plus 1. I'm going to leave out the 0x at this point because I don't need it anymore. So this up here is what we get when we divide the top by the bottom. So I've rewritten it. So now over here, I'm going to use this as my new integration problem. So I'm going to put 1 plus x over x squared plus 1. Oh, this should have had the dx. I forgot to write that in there when I did it. This is now my new integration problem. To integrate that, I'm going to separate it into 2 problems. 1 dx plus the integral of x over x squared plus 1 dx. And if you think about this, The integral of dx is just x. This is now a natural log situation where we have some form of the derivative over the original. Now, if this is x squared, the derivative of x squared would be 2x. So I need to put a 2 in front, offset that with the 1/2 so that I haven't changed its value. Now I have the derivative over the original. So I have plus 1/2, the natural log of the absolute value of x squared plus 1. Plus c because it was not a definite integral. So we have forced this thing to be a natural log situation by dividing the top by the bottom. Here's another example where the top degree is higher than the bottom degree. In order to get the antiderivative of that, I'm going to divide the top by the bottom. Now that says x squared, the x term is missing, so I need a plus 0x minus 2. And then on the outside, I have an x plus 1. I'm going to take the x and divide it into x squared. X goes into x squared, x times. I multiply, that's x squared plus 1x. I subtract. X squared minus x squared is 0. 0x minus 1x is negative 1x. I bring down the next term. Now I take the x and go into negative 1x. That goes in a negative 1 time. Negative 1 times x is negative 1x. Negative 1 times 1 is negative 1. Again, I subtract. Negative 1x minus negative 1x is 0x. Negative 2 minus negative 1 is negative 1. That is my remainder. So I put the remainder over the divisor. So this one has 3 terms in its rewrite. So I'm going to go back over here. I'm going to rewrite it as x minus 1 over x plus 1 dx. Then I'm going to rewrite that as 3 separate integrals. The integral from 0 to 2 of x dx minus the integral of dx minus the integral of, I'll say that's dx over x plus 1. To do this term, that would be x squared over 2, or 1/2 x squared, minus antiderivative of dx is x. Oh, all of these should have a 0 to 2. I missed those. Minus, that is the derivative over the original, so that's minus the natural log of the absolute value of x plus 1. Now, all of these are going from 0 to 2. So now I can plug in my a and b to get the final answer. So if I plug 2 into each of these, 1/2 times 2 squared, 1/2 times 4 is 2, minus 2, minus the natural log of 2 plus 1 is natural log of 3. That will be minus what I get when I plug in 0. Well, that's 0 minus natural log of 1 is also 0. So my answer, 2 minus 2 cancels. I end up with negative natural log of 3. It would not surprise me on the AP test if they gave you one like this that was in the non-calculator part of the test, because there's nothing wrong with this answer. Here's another example. Go ahead and pause the video, see if you can get it on your own, and then I'll give you the answer in a minute. Okay, so looking at this one, I'm going to rewrite first because the degree of the top is higher than the bottom, so I did a long division. I put the top underneath, the bottom on the outside, and then I did long division. That gave me an x plus 2 plus 5 over 3x minus 1. I moved that over here, and that's what my new problem is. That's what I'm going to integrate. I separated it into 3 parts. This part would be 1/2 x squared, this is 2x, and this is your natural log part, 5/3 times the natural log of the absolute value of 3x minus 1. This was a definite integral, so I plug in the 2 first. When I plug 2 in, I end up with 2 plus 4 plus 5/3 times natural log of 5, minus what I get when I plug in 1, which was 1/2 plus 2 plus 5/3 natural log of 2. I use my calculator. They're not going to give you one this complicated without calculator use. So I used my calculator for this next part, and I added up all the rational parts of this. So that ended up being 7/2. And then I took the two natural log parts and put them together. They both had a 5/3 in front, and then it was natural log 5 minus natural log of 2, and I rewrote that using my properties for natural logs. And so that gives me 7/2 plus 5/3 natural log of 5/2, and that is 5.027.